Hey guys, welcome back. Module 3.07, using formulas to solve problems. It's pretty much exactly as the title says. We are just going to be using formulas to solve problems. So the formulas are going to become very important. So what I suggest is when we see a formula, write it down on a piece of paper. Have it next to you somewhere so you don't have to continue going back looking for it. You have all the formulas on one piece of paper. So I've already written down several here. I think there might be a few more than this that I need to add, but these are the three that it gives me right at the bottom of this page. So I went ahead and wrote them down so that I can use them when I need them. Now, for the most part, a lot of what this stuff talks about, if you want to read it, is just kind of, obviously what the shape of a cylinder is. You can see, radius at the bottom, height of the cylinder. For a cone, you got the radius of the base at the bottom, radius of the circle there, and then the height of the cylinder. And then, of course, the sphere got the point in the center, right? And basically, it just kind of tells you a little bit about these shapes. But that's not where the math is. The math is, in using the formulas. So that's really what I want to focus our attention on. So I'm not going to go through all the kind of explaining of things as far as like where the formulas come from or how they're derived, because I think a lot of this talks about how the formulas are derived. Like for example, this one tells you how the formula of a cylinder, volume of a cylinder comes about. So no work to be done there. I kind of want to focus the attention in this video mostly on the problems at hand. But it is cool if you check out all this stuff, like the volume of a pyramid. I never knew this before. Like a pyramid. If you took 6 pyramids and put them all together, you would make a cube. So imagine if you had 6 pyramids in front of you, they were all the same size, right? And you pieced them, you kind of stack them together like this, you'd end up making a cube. And there's 6 of them, which is why the formula has, you could see how it kind of derives the formula 1/6 of the base cubed, and then it goes all this fancy stuff to end up with 1/3 base times height. Now that's a formula I don't think I have written down. So 1/3 base times height, volume of a pyramid. So let's write that down. Add it to my list here. Volume pyramid. And it was V equaled 1/3 base times height. So I'm going to continue adding more formulas to this list as I see them. And then, of course, later on, we'll see problems where we actually have to use all these formulas. So this is cool as well. Volume of a cone kind of shows you how they get the volume of a cone. I already have this formula down, so I'll be fine with that. All right, so now some examples, right? Now we actually have to do some work. So example 1, how much empty space is inside the can of tennis balls? The radius of each ball is 1.5 inches, and the radius of the can is 1.75 inches, and the height is 9 inches. Use 3.14 for pi. Round your answers to nearest hundredth. Okay, so we're going to have to find a few things. We're going to first have to find the cylinder's area in total, right? How much area can the cylinder hold? 1 second, real quick. So how much area can the cylinder hold? And then we'll also have to find out the volume of the tennis balls. So what we'll do is we'll find the area of the cylinder in total, and we'll subtract out the volume, volume of the cylinder as a whole, and then we'll subtract out the volume of each tennis ball, and whatever's taken out, the leftover is the amount of air, the amount of space in that cylinder. So let's try this out on our own before we look at these steps. So the first thing is I want to find the volume of a cylinder. So I have the formula, and it tells me in the problem that the radius of the can is 1.75 inches and the height is 9 inches. So volume of a cylinder, let's go to that. So the volume is going to equal pi. Now the radius was 1.75. We're going to square it, and then the height was 9. So we're just going to take our calculator. So give me a second. I should have loaded that previously, but didn't. If you want to fast forward 10 or 15 seconds, that's fine while this loads. Okay, so we're going to use 3.14 for pi. Just close that. So 3.14 times the 1.75 squared and times 9. And that gives us 86.54. We're going to round that up to 55. So 86.55. So the volume here is equal to 86.55. So that's the volume of our cylinder. Now let's find the volume of each tennis ball. Now the tennis balls were all 1.5 inches in radius. And remember, tennis ball is a sphere. So we're going to go to the volume of the sphere. We'll calculate it here. So volume is equal to 4/3 pi, which is going to be 3.14 for us. And then the radius was 1.5, so 1.5 cubed. So let's type this in our calculator now. So as for 4/3, I'm just going to hit parentheses 4 divided by 3. Oops. That's going to give me 4/3. Let's multiply that to pi, so 3.14. And then multiply that with the 1.5 squared. And we end up getting 9.42. Did I? Oh, it's not squared, it's cubed. My bad. I was going to say that didn't seem like it was right. Hold on, I got to go back and change this squared to cubed. Very important part of the formula, so you don't want to miss that. So that's 14.13. That's the right value. So volume here is equal to 14.13. So this is the volume of each tennis ball. Now remember, there are 3 tennis balls in the container. So we're going to multiply this value by 3 to get the volume of all 3 of them together. So we'll take that number, we'll multiply it with 3, and that gives us 42.39. So 42.39 is the volume of all the tennis balls. So our cylinder has this much volume, but the tennis balls all together have this much volume. So the space that's left over will be the difference between those values. So if we just take 86.55 and we subtract the 42.39, the answer is going to be the volume of space left in the cylinder, left in the container. And so I'm not going to do that on the calculator. I mean, you guys know how to subtract. Let's just go to the answer. It should tell us back on here. You can see it's doing the subtraction. It gets 44.16 inches cubed. So a matter of just using your formulas, really. Okay, example 2. So farmer wants to fill his silo with grain. Find the volume of the silo pictured. So the radius of the cylinder is 10 feet, the height is 30 feet, and the radius of the cone is 10 feet, and the height is 10 feet. So we're going to have to find, if you look at the picture here, we're going to have to find the volume of the cylinder and the volume of the cone and add them together, it seems. So let's do that. So the volume of the cylinder first. Now, the cylinder is 10 feet in radius and height is 30. So let's go back to our cylinder formula. So the volume is going to equal pi. So, well, let's just go ahead and use 3.14. So 3.14 times the radius. I forget the radius. Was it 10 feet? I think it was 10 feet. Yeah, 10 feet and the height is 30. So the radius is 10 feet. So this will be 10 squared. And then the height is 30. So multiply all this together and we'll have the volume of our cylinder. So again, really just using a bunch of formulas, right? So 3.14 times 10 squared, which I mean, I think we all know is 100, but we'll put it in there anyway, times 30. And we get 9,420. So volume equals 9,420. Let's double check to make sure that that is correct, and that's what they got there, so that's good. Now let's find the area of the cone that's on top of the silo. So the cone has a radius of 10 feet and a height of 10 feet. So we have to go to our cone formula. Let me erase this one here because we don't need that. Cone formula is volume equals 1/3 pi, which we're going to use 3.14. The radius was 10 feet, so this would be 10 squared, and the height was 10 feet as well, so that would be 10. So again, just plugging everything into the formula, and using the calculator to work it all out. So 1/3, again, I'm going to type it in as a parenthesis 1 divided by 3. I think that's the best way to go about it. Times the 3.14 times the 10 squared. Now, if you guys are using a different calculator than mine, if you're using a regular calculator, what I would do is I would put this in parentheses 10 squared just to be safe. Because you never know how it's going to calculate that exponent with other calculators, and then times 10 at the end. So that's a formula all typed out, and we get 1046.67 if we round up. So 1046.67. All right, so if we just add these two values together, we'll have the volume of the entire silo. Because remember, this was just the cylinder part, and this was the roof cone part. So if you combine them together, you get the total. That's what they should be doing in step 3. Yeah, they combine those values together, and they get their total. So it's just, again, like I said, using the formulas, just plugging in the values of the formulas. So make sure you've written the formulas down, because you're going to be needing them a lot. So this is pyramids again, gives you the volume of a pyramid. We've already kind of talked about this. So I'll let you guys kind of analyze this if you're interested, but let's get into some of the more mathy stuff. All right, so find the volume of the square pyramid below. Okay, so here's our square pyramid. We already have our pyramid formula. Let me erase all this stuff since we don't need that anymore. All right. So our pyramid formula is here. It's 1/3 base times height. And it looks like our pyramid has a base of 30 meters and a height of 8 meters. So, okay. Here's something that we need to know about the base. All right. So the base is an area. So really, hold on. What this should be, let's change the formula to base squared. Okay. So it's kind of like the length or width. You can see that in this picture, the pyramid has a base length of 30. It's a square pyramid, of course, so all sides of the base are 30. So we're going to have to calculate the area of that base. And to calculate area, you do the length times width. So 30 squared should be 30 times 30, because the width here would also be 30. Right, that's going to get us the area of the base. Okay, so that's what we're going to need. You'll see that's what they're doing here. They're using B. They're putting 900 in for B. They got B as just the S squared. S being, I guess, the kind of length here, right? So I wanted to make a little small change to the formula so that it's more kind of accurately presented. So when we just plug everything in, we have volume equals 1/3. The base was 30, so we're going to do 30 squared. And then the height was, forget how high it was, 8 meters. Plug in 8 meters. There we go. So now we've got our formula put together. We just got to type it all out. So let's see. We're going to do 1 divided by 3 for the 1/3 again. The base being 30 squared. So let's type in 30 squared. And then lastly, we are multiplying it by 8 because that was the height. And we end up with 2,400. So volume equals 2,400 cubic meters. So there you go. Again, this kind of works it out. It does tell you what to do, but in case you got confused about the B equal S squared thing, if that didn't make sense to you, that's just, like I said, they're talking about finding the area of the whole square at the bottom. So they're just taking the length times the width, but remember, since it's a square, the length and the width are both 30, and 30 times 30 is 30 squared. So it's just saying S squared being the square at the bottom, okay? And then, of course, you put it in your formula and you're good to go. Was there a second example? I think it was, yes. Okay. So the Great Pyramid of Khufu, I don't know. The length of the base edges are 755. So 755 feet is the length of the base edges. So since it's a square pyramid, it's 755 for length, 755 for width. The original height is 481 feet. Over time, the Pyramid of Khufu has gotten shorter. The current height is 449. Find both volumes and determine how much volume has been lost. Okay, so we're going to have to do the volume formula twice. So we're going to do, the base was 755. So let's go to our formula, volume of a pyramid formula. So the volume is equal to 1/3. The base was 755. And the height, let's do the original height first. So the original height was 481 feet. So 481 feet. Now remember, we have to square this base. So don't forget that. That's why I mentioned it previously. So 755 squared and then times the height of 481. So it's going to be a huge number. But we'll take our calculator and we'll see what we get. So again, we'll type in parentheses 1 divided by 3 times the 755 squared. So 755 squared. Don't forget the squared. And then times 481. I can only imagine how big this number is going to be. Okay, really, really big. I can't see them all at the same time. So 9,000, or not 9,000, but does it even show it up here? Yeah. Okay, so it's 91,394,000, right? 91,394,000. So 91,394,000 and like 88, I think it said. No, just 8. 08. 0.33, as if that really makes too big a difference here. All right, so that's the original volume. So now we'll do this again, but with the new modern day volume, because remember it got shorter. So the volume is equal to 1/3 755 squared. And then the new height was, or the current day height is 449 feet. So we're going to put that in here. So 449 feet. So again, just put this in the calculator. I'm just going to kind of copy and paste this to make it faster. We're just going to change this to 449. Everything else stayed the same. And this is equal to 85,313,000. So let's see, 85,313,000. 741.67. 741.67. So this is the original volume. This is the modern day volume. So if you want to find out how much volume was lost, just subtract those two values. So if I subtract them, it's probably going to be about 6 million something, right? I'll let you guys take a calculator and do that. But of course, this should already do it for us. Yeah, you can see they just subtract those values and they get about 6 million something cubic feet. So really big numbers on that problem. So don't be too concerned if you're noticing that. All right, so again, more practice with formulas. Find the circumference and area of the circle below. So it didn't give us these formulas previously, but just so you know them, let me add them to our list. So circumference formula. So circumference, just to abbreviate it, is C equals, let's do it in red. C equals pi r squared. And you'll see that, I believe it does give it to us. Yeah. Pi times d is, I'm sorry, I got the area formula and the circumference area confused. All right, so circumference is pi, 2 pi r, sometimes people say it, or just simply pi times d, and the area was pi r squared. So see, this is why you have to write them down, because it's very easy to get them mixed up. So the reason why both of these formulas could work for circumference, let me actually put area on this one. So area of circle. Area, like I said, was A equals pi r squared. All right, so the reason there are two formulas here is because d means diameter, and diameter of a circle is the full length of the circle, right? So look, I kind of drew a Pokeball. Isn't that cool? No, I'm just kidding. All right, so diameter of the circle is basically two of the radius, right? Because the radius is one length, and then the radius of the other side, basically diameter is double the length of the radius. So the D and the 2R are the same thing because 2R is just saying double the radius. So that's why you'll sometimes see it as 2R or just like 2 pi R or pi B, because they are really essentially the same thing. So whichever way you want to write the formula, whichever way you want to use the formula is fine. So if we wanted to do it with this problem, the radius is 6. So you would just type in for circumference, you would do C equals 2 pi times 6, which is going to simply be 2 times 6 would be 12. So 12 times pi, we just type that in our calculator pretty easily. So 3.14 times 12 is equal to 37.68. Which is what they get. And of course, if you want to find the area, just use the area formula. So your area would equal to pi and then 6 squared. So 6 squared, of course, is 36. You can just type this in the calculator, but pi times 36, we get our answer. So 3.14. 3.14. I'll just type it in as the 6 squared. So times 6 squared is equal to 113.04. And you can see, again, that's the value they're getting. So add those formulas to your formula sheet. All right, let's try this one. Find the volume of a cylinder with a diameter of 4 centimeters and a height of 5 centimeters. So going to our cylinder formula now. So our cylinder formula is all the way over here, all the way to the end. And what criteria did it give us? It said that the diameter is 4. Now keep in mind, diameter is not the radius. Diameter 4 is in height of 5. Now, here's something to be very mindful of. When it says diameter, okay, equals 4. Diameter is not part of our formula, right? We need radius, okay? And I just mentioned this. Diameter is double the radius. So if the diameter is 4 and the whole length is 4, then the radius is half that length, which means the radius is going to be, for this problem, 2. So for us, we're going to be plugging 2 in for the radius. So we're going to have volume is equal to pi, and then 2 squared, not 4 squared, because remember it's the radius, not the diameter, as we just mentioned, times the height. What height did it give us again? It said the height was 5 centimeters. So 5. Of course, we're going to use 3.14 for pi. So we're going to type this into our calculator now. So we're going to do 3.14 times 2 squared times 5. And we get 62.8 for the volume. Yeah, it tells you again, the radius is 2, not 4. So make sure you understand that. And we get the same result. So practice problem 3. The volume of a sphere with base edges of 100 meters. What does that mean, base edges of 100 meters? I'm kind of confused by that. So let's see if I can understand what they're saying here. Oh, it's a pyramid. I thought it was a sphere. Did I say sphere? Volume of a square pyramid. That makes sense. I was thinking of a sphere for some reason. So again, lesson learned. Make sure you're paying attention and reading the problem carefully. So a square pyramid. Edges of 100 and height of 60. So square pyramid. All right, so our volume is going to be equal to 1/3. Edges is 100, so we're going to do 100 squared. And then the height, I've already forgotten, is 60. So again, there's a formula. We just got to simply type this into our calculator. So 1/3, again, it's just 1, in parentheses, 1 divided by 3, times the 100 squared. So 100 squared, and then times 60. Let's put this in parentheses, times 60. And we get 200,000. So the answer there should be 200,000. Yep, and we're good. So again, just make sure you read the problem carefully. We got 2 more, and that'll be it. So a cone is shown below with a radius of 7 meters and a height of 24 meters. What is the volume written in terms of pi? So it's kind of interesting how they said in terms of pi. So I'll show you that. It's actually easier to write it in terms of pi, but maybe more confusing, but easier, if that makes sense. So the radius is 7 and the height is 24. We're looking at a cone. So volume of a cone, that's over here. So volume is equal to 1/3 pi. The radius was 7, so we're going to have 7 squared. And then I've already forgot the height again because I have a terrible memory. Height of 24. Now, in this case, it says write the answer in terms of pi. So we're not actually going to plug in 3.14. We're just going to try and simplify all the numbers instead. So to simplify all the numbers, we're going to just, 7 squared times 24. Let's figure out what this is real quick. So 7 squared is 49. You can type it in, 7 squared if you want. 7 squared is 49, but 49 times 24, or 7 squared times 24 is 1,176. Okay, now remember we have the 1/3. So what we're going to do is we're going to take a third of that number. So let me kind of do that in the next step. So 1/3, what number did we just get? We got 1,176. So 1/3 times the 1,176, or essentially just dividing it by 3. But if you want to just think of it as multiplying, you can. So 1 times 3, or I'm sorry, 1 divided by 3, 1/3 times the 1176 is this. And again, it's the same thing as just taking 1,176 and dividing by 3. But we get 392. So all the numbers combined gives us 392. And remember, we never really touched the pi. All we did was simplify all the numbers. So 392 is all the numbers, and the pi would still be there. So if we want to find the actual value, then of course we would just take 342 and times it by pi. But since it wants the answer written in terms of pi, we're going to leave it written with the pi symbol. So 392 pi is how we're going to leave the answer. And so that's where they're getting that from. So that was a good one to do. And then one more. ABC Cheese Company sells 2 popular products. One is a block of cheese in the shape of a rectangular prism, and the other is a block of cheese that starts as a rectangular prism and then is sliced into congruent pieces that are parallel to the base. If the solid block of cheese and the slices share the same base area and height, what relationship can be concluded about the volumes of the block of cheese and the sliced cheese? Doesn't give, so it's not really a math problem. It's just kind of your understanding of all these shapes. So let me read this one more time. One is a block of cheese in the shape of a rectangular prism. Okay, so kind of like a longer cube, I guess. And the other is a block of cheese that starts as a rectangular prism, but is then sliced into congruent pieces that are parallel to the base. So yeah, just take a block of cheese and slice it up is basically what it's saying. If the solid block of cheese and the slices share the same base area and height, what relationship can be concluded about the volumes of the block of cheese? I'm just going to kind of read this, see if I can make sense of it. You can infer that the sliced cheese started out with the same dimensions as the block of cheese. The cheese on one block was then sliced into congruent pieces parallel to the base, creating a series of rectangles. Even though the cheese was sliced, it will still have the same volume no matter how the slices were arranged. So it's kind of just saying if you cut a block of cheese up into a bunch of different slices, it's still, all that cheese is still the same volume. That kind of makes simple sense, right? Because if you imagine all the slices of cheese, if you were to put them all back together, you'd still have the exact same amount of volume you started with the block of cheese. Very strange. I don't know if there's going to be something about that on the quiz or not, but no math involved. Very odd thing to think about, but it works. So that's going to be it for the video. I'll see you guys. Well, I don't know if I'll see you guys anymore, but good luck on your next assignment. And again, let us know if you have any questions. Okay? Goodbye. Bye.